Welcome to What's New with BigQuery. I'm Oliver Ratzesberger, Vice President of Product for Data and Analytics at Google Cloud. I'm very excited to be here and share with you what's new with BigQuery. Together with my fellow speakers, we'll take you through an action-packed session today. In fact, this is probably going to be the most exciting session of the whole week. Woo! So, today, we're going to talk about the unified data platform. We're going to talk about what's new with BigQuery, and there is so much new in there. Today, we're going to cover the roadmaps, the announcements, and we will hear from Deutsche Telecom how they use BigQuery to build their one data ecosystem in a highly complex and regulated environment. Before we get there, in a recent survey, 80% agreed that lines between data and AI are starting to blur. As those lines blur, organizations that are not able to bring AI directly to the data do not have the ability to maximize the impact of AI. Organizations that are unable to tap into unstructured data are missing out on a massive opportunity. And organizations, of course, are hugely limited by skills and talent. This is how Google Cloud, the Data Cloud, can help you harness the power of data and AI. First, you need an AI-ready platform that allows you to bring structured, unstructured, multimodal data together with multiple engines and in a multi-cloud environment. Second, you need to bring AI to the data, not the other way around. There's no way you can copy data towards AI algorithms, so you need a platform that has AI built into the platform. So you can leverage the LLMs, the embeddings, the vector databases. And third, you need to empower the organization through AI with assistive features that help you do more work with less human intervention. And BigQuery is that one platform, a unified platform that helps you bring all of this together. And we see enormous momentum with our customer base. Just in the last year, the amount of unstructured data analysis has grown by over 600%. Adoption of serverless Spark as an engine within the platform has grown by over 500%. And all of that while being the lowest TCO platform out there, with 54% lower TCO than competing cloud platforms. Since the initial launch of BigQuery 13 years ago, we have focused on building a platform and a lot of capabilities. Just last year alone, we released over 150 new features in BigQuery, and there's a lot more to come. Many of these features came from recommendations or requests from you, our customers. So keep telling us what you need, and we will innovate on your behalf. And so today, we're bringing together BigQuery as a unified platform. And BigQuery is evolving into a platform that allows you to bring different data formats together, structured, unstructured, multimodal, across multiple clouds, with multiple engines. It's no longer just SQL. It's serverless SQL, serverless Spark, serverless Python, and there will be additional serverless engines coming this year that will really make this the most powerful platform on the planet. And we're integrating it with AI and with Vertex AI directly into the platform so that you can interact, train, and deploy LLMs and pick from over 130 different models from Model Garden in Vertex AI and use them directly within BigQuery. And ultimately, bringing Gemini into BigQuery so that you can get the help of the leading LLMs and create powered assistance by Gen AI to help you deliver on your journey. Gemini in BigQuery helps the data teams reimagine data and AI experience. It goes beyond code assistance. It helps with data ingestion, pipeline creation, quality monitoring, and assisted analysis, system optimizations, and troubleshooting. Gemini in BigQuery helps enhance data users' productivity, optimize cost and performance of data workloads, and proactively monitor and prevent data and governance risks. Today, we are covering 4 areas of innovation with BigQuery that support a unified data platform, a unified experience, data to AI integration, and new enterprise features that you, our customers, have been asking for. With that, I'm going to turn it over to Irina Farooq, Senior Director of Product Management at Google Cloud.
Thank you very much, Oliver, and good morning, everyone. Are you as excited as I am about BigQuery being the unified platform? I know I am, and I am going to share some things which we think explain what it means to be unified and why that foundation is really important for your data to AI journey. And so if we get started, last year we introduced BigLake, which is that unified storage engine across BigQuery native storage and data stored in open formats. We have made an important commitment to give you the flexibility to store data in the format of your choice, taking advantage of the industry innovation while getting all the fine-grained security, performance acceleration, governance, and that unified seamless BigQuery experience that you know and love. So today, we're extending our support for Apache Iceberg with full managed experience with DDL, DML, and streaming support. We are adding native support for Delta Lake, and we are adding federation for spanner databases. So think of it as BigLake being your foundation for unifying all of your data and getting it ready for a variety of use cases within your organization. As Oliver talked about, a lot of value is stored in unstructured data, images, audio, text, and most people don't even know where that data is or how to discover it, much less get value from it. Last year, we introduced object tables, and now we're bringing much more capabilities of integrating all the way to cloud AI with document AI, speech AI. So now you can start extracting value from that unstructured data in the same governed and consistent way across the platform. All of that is possible with powered by a single runtime metastore that provides a consistent view across your data. So you don't have to think about open source ecosystem or partner ecosystem or Google native ecosystem. You just think about your data, and a table created in Spark is surfaced in BigQuery and available to your partner tools, really reinforcing that commitment and consistency across the unified platform. But as much as we would love it so, we know that the bounds of your data don't stop at GCP. And many of you have data that's on AWS or Azure, and you want to combine that data and analyze it together into a single set of use cases and experiences. And this is where BigQuery Omni and our investment here really comes in. BigQuery Omni is very unique in the way that it helps you analyze data across cloud with cross-cloud joins and cross-cloud materialized views. And now today, we're also announcing bidirectional data sharing with Salesforce Data Cloud, being able to leverage the Salesforce data, again, with zero ETL in your analytical use cases. Anybody here is using streaming data or thinks streaming is really important for real-time applications and real-time ML? But the reality is that streaming pipelines are really complex to set up, and in many cases are even more complex to manage. And this is where we're making streaming in BigQuery dramatically simpler with continuous SQL queries in BigQuery. So now with just a few lines of SQL, you can do continuous SQL over your data streams, and all of that data is immediately analyzed and available at BigQuery scale. So as you unify your data and you make it available to users within your organization, governance becomes dramatically more important. How do you make sure that you manage your data and make it accessible to the right users and their tools of choice while ensuring compliance policies and your own corporate policies are enforced? I'm excited to share that we've brought a lot of the Dataplex management and governance capabilities directly into BigQuery. So in addition to lineage and data quality, we've now embedded data to AI catalog, where all of your data assets, AI models, features, pipelines are all available and visible within BigQuery. You also have end-to-end lineage that we've extended all the way to Vertex AI pipelines, so you can see end-to-end lineage and provenance of your data all the way through your pipelines. And for at-scale management, having at-scale governance rules, so you can codify the best practices and automatically apply those policies for fine-grained access control as new data shows up, new users show up, and new use cases really show up within the organization. And last but not least, one of the most requested features is the column-level lineage is now also available in preview in BigQuery. One of the things many of us love about BigQuery is the true serverless nature of the platform. And serverless is this vague word, like is your serverless more than my serverless, more serverless than mine? BigQuery is truly serverless, right? This is really the true advantage of no copying of data, no clusters to manage, no infrastructure to think about. And as we unify into the broader single data to AI platform, we're committed to keeping that promise across all of the use cases that we support with BigQuery. And so I'm excited to announce that the serverless Spark Oliver talked about that has seen tremendous growth now is directly available in BigQuery Studio with the same serverless experience that you know and love. You can use Write by Spark inside BigQuery Studio. You can save the notebooks and automate them with BigQuery workflows. You can save them in stored procedures and then make them available to your analysts to use in their day-to-day workflows. All of that seamless experience across all of your data. So now, as we come to unified experience, next, we announced BigQuery Studio. Since then, 7-8 months ago, over hundreds of thousands of users are using the BigQuery Studio. And now, at this next, we're announcing GA of this experience. Pardon me. I got overexcited about BigQuery Studio GA, lost my words. Really meant as a single unified workspace for all of your data teams to collaborate in their preferred tool of choice, whether it's SQL, Python, PySpark. All of them can collaborate together within this single experience with full source control and revision built into the BigQuery Studio. We also, Brian is going to talk about, there's a lot of new natural language and Gemini capabilities, as you imagine, coming into BigQuery Studio, announced at next as well. The other core capability of the unified experience is the BigQuery workflows. That's our new capability about your low-code way to orchestrate and manage pipelines across your environment. So whether it's SQL script, Python notebooks, or your data canvases or data preparation assets that you've built within BigQuery, you have a drag-and-drop interface to simply orchestrate those and a single place to manage all of your workflows across the system. Anybody heard of Gemini? Very excited to announce some of the new Gemini capabilities in BigQuery. Code assistance is a key capability of being able to use natural language to generate SQL and Python. Code completion, both code completion generation, as well as an in-context experience to help you learn and understand how to best leverage BigQuery inside the BigQuery Studio. Gemini also gives us an opportunity to rethink what are the new experiences that were not previously possible that we can deliver for our end users. And Data Canvas is that new experience, where it's natural language first, iterative experience, where you can visually explore your data and iterate as you explore and analyze and visualize your data, and then collaborate with the rest of your data teams. Data preparation, many of us know, can be a very manual and complex task. And this is one area where we really set out to automate with Gen AI-powered assisted data preparation experience that helps automate things like schema matching, business data quality rule identification, and really is your always-on assistant for automated data preparation. One of the biggest challenges that we hear from our customers is the cold start problem. I don't know what data I'm looking for, or my end users don't necessarily know what insights they could glean from their data. And data insight is the capability to help drive that, where you can come in and you say, I'm looking for sales data. And it can tell you top 5, 10 insights that you can glean from your data based on the understanding of semantics, metadata, as well as the patterns within your organization of what other users are using to help answer similar questions. And at that, for those of you wanting to build your own AI applications, I'm going to hand it over to Brian Welcker, Director of Product Management, to share the data to AI integration.
Thank you.
Thank you, Brian.
All right. Thank you, Irina. It's great to be here in person at Next 24. This is actually the 4th year that I've done this presentation. The first 3 were virtual, so it's really great to have everyone here and be able to share what we're working on. I'm going to start off with some of the new data to AI capabilities that we've built right into BigQuery. It all starts with BigQuery ML. Back in 2018, we were the first cloud data warehouse to say, hey, what if we took machine learning and put it right into the data platform? Right? What if we made it so easy that a data analyst or data engineer could use SQL to build a model, to train a model, and then run predictive analytics on that model? And it was kind of a new thing at the time, and since then we've continued, excuse me, we've continued to innovate, and a lot of these innovations are about taking Google AI and the things that are going on in Vertex AI and just bringing them into SQL and making them available. So we've got lots and lots of models that we've built and new capabilities. Some of the latest things we've done is advanced modeling capabilities like new multivariate and hierarchical time series forecasting, along with advanced holiday modeling. We've got an explainable AI that will tell you why the model predicted what it did, what the inference was for. We've got advanced feature engineering where you can do the pre-processing during model creation, so a lot of new capabilities there. And then, of course, the big thing is around LLMs and around remote inference. So BigQuery ML has always been about building your models inside of BigQuery, but we added the capability to say, hey, you've got a model in Vertex AI. We want to link to that. We want to use that model, but we don't want to necessarily build it within BigQuery. Now, once again, the data doesn't move. It's not like we're making a copy of your data in another store and then calling the model. We're leaving the model in BigQuery. We're calling that, leaving the data in BigQuery, calling the model in and getting that ability. So the big thing there is we built on top of that the ability to use generate text embeddings, and be able to leverage all of the models in Vertex AI. Those could be first-party models like Gemini. Now you can access Gemini 1.5. But they can be open source models and they can be third-party models as well. We recently, just last week, did supervised tuning. So instead of having to start with a generic base model, you can tune the model with your prompts, and then you can actually start from that, load that tunings in, and then start from that model during your prompt generation, during your ML work. So great features there. Really, the things that you can do with BigQuery ML are truly endless. So things like sentiment analysis. And because you have it right with your discrete data, you can combine your discrete data with the things that are coming out of the model. So imagine analyzing the sentiment of customer conversations, correlating that with the lifetime value of the customer. Enriching your data. Maybe you've got a little bit of geographical data and you want to add additional geographical dimensions. Easy to do with LLMs. Extracting entities, whether that's text entities, whether that's conceptual entities or entities from what's in this picture, what happened in this conversation, and then being able to combine that with your discrete data. Generating content, so personalized messages based on customer purchase history, based on customer attributes, and then translation. You want to be able to have your reps look at conversations you're having with the customer, whether or not it happened in their language or not. So really, it's unlimited. With just a few lines of SQL, you can unlock these use cases. We only launched the ability to generate text late last year. We've got tons of customers who are building really amazing things with BigQuery ML and remote inference. So it starts with being able to use LLMs and generate text, but really vectors take it to the next level. So the vector is the semantic representation of an entity, and you can use vectors to do things like retrieval augmented generation. So instead of generating the text from the model, you generate the vector, and you store that as a set it's an array of numbers, a very dense array. And then you can do things like semantic search. You can say, what are entities that are similar to this entity? What are responses that are similar? What are images that are similar, right? So it's a super powerful thing, but up to date, people have had to have separate vector databases and to store that information. So you had your database with your business data, you had a separate database for your vectors, and you had to keep those in sync. And so that's why we recently put vector search capability directly into BigQuery. So you can create an index on a table, and then you can, on top of a vector information in that table, so let's say you've got customer responses and you vectorize that data, and then you index it, and then you can do semantic lookups on it. You can say, what are other customers that are like this? What are other products that are like this? And those stay in sync, right? So as you're manipulating the data in BigQuery, those vectors are automatically kept in sync. They're also kept in sync with Vertex AI. So you can use those same vector indexes when you deploy the models and support them in production. So just a few lines of SQL, create vector index, and then a vector search functionality, really bringing the power into your data analysts and data engineering teams. Now, we didn't forget about the data scientists as well. And we know that SQL is a great language for analyzing data, but Python is super powerful as well. So we've been working on something called BigQuery Data Frames, and I'm excited to announce that Data Frames is now generally available. What we've done is we've implemented over 700 Pandas APIs directly in BigQuery, and behind the APIs, we're translating that into BigQuery SQL. So when you're working with data frames and you're manipulating those data frames, you're not bringing them back into the notebook. You're not pulling that data back across the wire into the notebook. You're using the power of BigQuery to do all of that data manipulation. So you get both scale and ease of use. We've also integrated the scikit-learn APIs, so you can do model training, model evaluation, and all of the end-to-end data science work, once again, directly inside of BigQuery. All of that's translated into BigQuery ML behind the scenes. And really, these data frames allows your teams to build Vertex AI applications really easily using the power of BigQuery. You can also use these you can integrate with other application frameworks as well through data frames. So I think a great example of a customer who's really leveraging the power of AI and bringing that to their data is Wayfair, a great partner and a great online retailer. They rely completely on Google's Data Cloud for all of their work, all the way from experimentation to deployment to monitoring, a single place to bring all that data together and make it available for AI to do predictions to help their customers. They can take advantage of the multimodal data that Irina talked about. We talked about all the power of LLMs and Gen AI right in that environment. And then once again, they get that end-to-end governance. So when you bring the data in, you clean the data, you prepare the data for the model, you model the data, you predict, all of that lineage together in a single data platform. All right, so the last thing I'm going to talk about is some of the enterprise capabilities of BigQuery. Once again, many of these were requested by customers like you. Sometimes they take a long time to build, but we keep at it, and we're happy to announce several new ones here. I'll start with query performance. We're always working on query performance in BigQuery. And the great thing about BigQuery being a multi-tenant, massive service is that you don't have to do anything to get this. You just come into work, and then BigQuery is faster than it was the day before. You don't have to change your queries. It just becomes a faster environment. One of the recent things that we just did is something called history-based query optimization. So when we have a query that we've seen before that's similar to other queries, we can use the execution plans from the previous execution in order to inform the latest execution. We're seeing, for some types of queries, up to 5x query acceleration by subsequent executions of the same type of query. We're also working on something that we just announced called small query performance. BigQuery has been known for processing terabytes, very large data sets, but we know also people want to power their dashboards and their reports with smaller queries as well. And so we're seeing for small queries where you're getting under a gigabyte scanned, we can turn those around in under sub-second, under 100 milliseconds response time, right? And so in that case, you really want to scale up high concurrency at low latency. So BigQuery, for your big queries that take minutes, hours, as well as for your small queries. We continue to invest in our BI engine, so that's our vectorized BI engine, has smart caching, so you can give it some memory. It does in-memory caching, and it will serve out data sets, result sets in subsequent if it's seen them before. And you get all this query acceleration no matter what tool you use, because we built it in to BigQuery SQL. You get transparent query acceleration from any of your SQL tools or your BI tools, so Looker, Looker Studio, Tableau, Power BI, really anything that calls into the BigQuery APIs. We have done some work for Looker Studio. We know a lot of you are big fans of Looker Studio. Over 40% of BigQuery customers actually have used Welcker Studio. And so job details, job monitoring, cost tracking, query caching, and then automatic query rewrite as well. So one of the features of materialized views is in BigQuery, if you have a query that can be satisfied by a materialized view, we'll rewrite the query, and then you'll get the benefits of the materialization. So that's now available from Looker Studio queries as well. Data sharing is also a key feature for enterprises, and we've been investing a lot over the last several years on data sharing. And the ability of BigQuery, because of its serverless architecture, to bring compute to the data enables these data sharing scenarios. So when you're sharing outside your organization, you're not making copies of the data. You're just making that data available, and then the subscribers, the users of that data, can bring their compute and run whatever queries they want against it, and it doesn't impact your environment, right? So having this serverless architecture really enables data sharing. And it really allows you to collaborate. We've seen a huge increase in data sharing. BigQuery customers are now sharing hundreds of petabytes a week. There's thousands of customers, and we've seen data sharing actually double in the last 8 months. So the number of cross-organization sharing, either as a publisher or a subscriber, has really increased. Last year, we announced something called data clean rooms. Data clean rooms extend our data sharing capabilities to allow for privacy-safe data sharing. So we use privacy techniques so that the subscriber has some limited access to the data. So they can do aggregated results, they can get analytical value out of the data, but they can't re-identify the individuals. So we use things like k-anonymity and differential privacy in order to enforce the privacy rules. Other features we've added in data sharing, including the ability to manage subscriptions, to understand how your shared data is being used, to giving you metrics about what tables are being used, what queries, type of queries people are running, support for user-defined functions, time travel, materialized views over shared data, and then finally, the ability to cross-cloud data share. So if you've got some data that's sitting on AWS and Azure, available through BigLake, you can bring that through BigQuery Omni, and then be able to share that with others through Data Sharing and Analytics Hub. Another long feature people have asked for is the ability to cross-region disaster recovery. And we know that business continuity is super important. Now, BigQuery within a single region has high availability. We always keep an extra copy of the data synchronously within a region, but we know that in certain places, in the unlikely case of an entire region outage, you need to be able to have business continuity. You need to be able to keep running your most valuable workloads in a second geographical location that's hundreds of miles away. So we've created something called cross-region disaster recovery. It's going to preview next week. And with cross-region disaster recovery, you set a set of databases that you would like to replicate. We'll keep those up to date in the remote region automatically. And then you have a set of compute on top of that. And we'll keep a set of standby compute in that second region. And so if it ever becomes unavailable, you can switch everything over to the second region. We'll promote the secondary to be the primary, and then the primary becomes the new secondary. At the time of general availability, we will offer a recovery point objective for all of your data within 15 minutes, so no data will be older than 15 minutes, and recovery time of under 5 minutes, which means you can get back up and running in the other region in less than 5 minutes. And the standby compute capacity is included in the price of Enterprise Edition. So we're not charging you an extra for that capacity that we're holding in case of a failover. And the other thing about failover that's the way we designed it is that the queries don't have to be rewritten. So all your queries will automatically be routed to the new region. BigQuery has a query router. We know that the failovers happen, and so we'll automatically route those queries over to the new primary region. Other features in this space for human errors, that's more from an infrastructure point of view, are in the data backup and recovery. Every BigQuery table comes with something called time travel, which is any deleted or changed data is in the table automatically. You can rewind that and you can see old versions of the data. We keep that around automatically. Table snapshots and table clones are low-cost copies of your data. Table snapshots are really good if you want to archive something, you want to hold on to it for a long time beyond that time travel window, and maybe restore it later. And then table clones are great if you want to have some data, say, in a production environment, clone it into a test environment, run some operations on that, it's a writable copy, and then make sure everything's working, and then you can get rid of the clone and apply. So really low-cost copies of tables. They're only metadata copies. So you can see on the right here that we only charge you for the differences between the base table and then the snapshot or clone. We're also recently announced something called cross-region table copy. That takes a point-in-time copy of a table, makes it available in another region, and dataset undelete is a long time. If you accidentally drop an entire dataset with one SQL command, you can undrop it, and it will bring it back, and you can keep going. Operational health monitoring is a way to get, am I running out of time? Okay, sorry, you're ready. You're almost ready. We've got two more. Operational health monitoring is a way to get a quick view into how BigQuery is running. Last year we did resource monitoring. That's the ability to see metrics over time, things like slot contention, queries queuing up. So you can see that history. You can drill into specific points in time and then take action on those. The Jobs Explorer gives you a total view of what jobs are running in your environment. So you can sort by user, you can sort by the amount of time the job's taken. The other thing you get in Jobs Explorer is you get some suggestions about, hey, this job used to run in a certain amount of time, and it's slower today. And then that could be because of slot contention, it could be capacity contention, it could be because the shape of the data has changed, but you might want to drill into that query and then go figure out what's going on with that. So Jobs Explorer is a way to do that. We have two other new views that we recently launched into preview. The organizational summary is giving you a high-level view of what's going on with those key metrics, and then the details view lets you drill into specific metrics. And all of these are available right in the BigQuery console. You don't have to go anywhere else, and they're fully integrated with BigQuery Studio, so you can go take a look at and make any modifications you want. And the last thing I want to talk about is the migration service. We know moving to a new platform can be challenging, and so several years ago we started investing in a set of migration tools. And these tools are completely free. All they cost is the BigQuery compute that, for running the queries, but the tools themselves are at no charge. So we support 15 sources now for schema and query translation, including things like Redshift and Oracle and Netezza and Snowflake and lots of sources. And then we have a new API if partners want to hook into that translation, that machine translation of the queries. Assessments, we've got 4 different sources. Assessments are a way to say, we've looked at your source system, here's how much it'll take to get over to BigQuery. And we give you a cost and we give you an estimate of the things that you're going to have to do. Migration of data itself, so not only moving the schema, but moving the data itself from either on-prem or cloud for 4 data sources, and then new programs to really help jumpstart those migrations. And then finally, in this space, we've got new Gemini-enabled enhanced translations. And so what we do is we have our automatic translations, and then we use Gemini to make further suggestions about how this query would work best in BigQuery. So kind of the last mile of query translations. And we've seen great results with BigQuery migration services, over 400% year to year, increase in the number amount of usage. We've translated tens of millions of statements into BigQuery SQL. And with that, I am excited to talk about a real-world scenario with Steffen Grimmel. He's the senior architect at Deutsche Telecom. He's going to talk about how Deutsche Telecom has taken the BigQuery and built their data platform. Steffen.
So thanks very much for having me. Before I start with really Google content, I start with something about Deutsche Telekom. We have about 250 million customers worldwide. We serve in more than 50 countries, and we have 112 billion revenue a year. You in the US might know us with our brand T-Mobile, serving with an own infrastructure here in the US. And we are the most valuable German brand ever, also being one of the top 10 global brands. And we are really striving to be the leading digital telco in the world. So directly start with the problem statement we had. We had problems of scale, problem of governance, and problem of operations with our legacy on-prem infrastructure. We have a massive complexity in the telco world. We ourselves have 55 systems on-prem, which makes it very complicated to deliver value, to get changes done quickly. We have governance problems, having different IAM systems, setting up analysts on multiple systems is quite a hassle. You will know it if you have same infrastructures. And we have multiple ingest and engineering frameworks, making it even complicated to get developers in and to get analysts in. Third problem statement we want to have is the operations problem. We have maintenance problems, license problems, and region-specific data control problems. So we are in a highly regulated market, and this leads to downtimes, to version updates and whatever. And it's more like coincidence if everything is up. So what did we change from legacy to a one data ecosystem? It's not really a technology problem that we have. It's more like an ecosystem problem. If you're an analyst, if you're a developer, you want to have like one data ecosystem. You don't care about having different technologies, different access methods, different technologies. We really want to have it like serverless. We want to have like a streamlined ingestion and engineering process that everyone is capable to do it in the same way. And further, we need really something like sovereign control to have CDR data and dial-up data available as we are in the telco market. Google gives us the capability to fulfill this. We mainly use BigQuery and Vertex AI with all engineering options you have in a platform like Google. And we really have a great focus about value creation. So it must be seamless and fast. We don't do IT for ourselves. We do IT to deliver a good experience to our customer, to be fast in the market, and be able to respond very fast to changes. Now let's get a layer deeper. Let's get to a technical perspective. We enabled a fully horizontally scalable ecosystem. We have different layers implemented. So we have a data layer, we have a compute layer, and an analytical layer. The idea is to decouple all the layers to adapt very fast in changes in technology. So if Google announces whatever technology we can use in one of those layers, we are able to adapt without changing the whole ecosystem. That's like the core idea of the whole hub. Further, we have spokes. So the most important thing about spokes is that they are not by choice, they are by constraints. The idea of our spoke is that we can instantiate parts of the ecosystem without making problems to our ecosystem. So we have the chance to trial things with parts that we just spin off and instantiate as spokes. One of them is Spoke AI, and I will go a little bit deeper on this in several seconds. Most important thing about being fast is having all your infrastructure as code, have policy as code, your whole IAM system and so on, and have integration into a full CI/CD chain and MLOps. So really get rid of everything that you do by hand, by opening a shell and deploy things and so on. This is more than outdated nowadays. So let's go a little bit deeper on the Spoke AI, as I introduced one of the core concepts when it comes to machine learning, to data mining, and to generative AI. So the idea is really that the core IAM processes and the choice of different tools and technology is always quite a hassle, even in big companies. If you work as an analyst, until you get your workbook ready and everything, your nerves are already gone. Yeah? So the idea is that we have like a fully secured environment where we have like a defined integration of workbenches, of metadata repository, of model repository, and the data access, so that you as a developer or as an analyst are fast to deliver and don't have all the hassles with IAM access, getting the right tools in place and the right libraries for the things you want to do. So unified data and the AI, as it was presented, will this make even faster and more easy for us as one of the customers of Google. So as we talk about one data ecosystem, the data lifecycle becomes extremely important. So we have the idea that we have one source of truth. Beforehand, I was talking about 50 sources of 50 systems. Each of them says we are the source of truth. So there might be a problem with having multiple sources of truth because that's not a source of truth. So now we have an atomic layer which is dependent on our sources, and everything up from the atomic layer is depending on the consumption. So the idea is that no source belongs to any project, to any value stream, to any specific purpose. It just belongs to the company, a set of Deutsche Telecom, to have everything in atomic layer. And if you're an analyst, it's like shopping in a grocery store, right? You just took the sources from atomic layer, develop your models, develop your capabilities you need. We use Iceberg as a file format for storage, and we have BigLake in place for a unified view. So our core idea is that we enable SQL and we enable Spark. We have heaps of developers, heaps of analysts in those technologies, and it would be a pity to leave them behind. So this was our design consideration. So last but not least, having a Cloud Composer with Airflow and dbt in enables us really to have a high degree of orchestration for end-to-end data value creation and getting this automatically delivered to our businesses. So the thing I want to come to, especially here today on this conference, is our LLM-infused generative software lifecycle. So the idea, I think every one of you knows software lifecycles. I don't go into this very deep. So the basic idea is here really to use the power of LLMs and alike models to be fast in setting up such a platform as we have in telecom. So up of now, we use Gemini to understand our sources. It really helps if you have like legacy sources to hand it over to developers and have like a description, what's in the code, what's really the purpose of the package, what's happening. Second thing that we are doing very much is we generate synthetic test data with Gemini that works really, really great. So if you have like developer teams, you want just to provide fully packages where they can work, just give them everything they need without getting access to your production in a regulated market. It's always quite a pity, even in offshore or in nearshore models. Third point we want to talk about is code generation. We do already quite much work with Gemini 1.5 to convert code that we have. It works great with, for example, SAS code. It also works great with Oracle PL SQL code and alike. So the first time I saw it, developers were making fun of me because I was expecting that they did it by hand. It was in such a good quality that I was not really believing them. So it's really a great thing if you just try to convert code, and the on-top thing that you have to do just to use Gemini to say convert code from technology A to technology B is to prompt to also use the technology-specific architecture pattern. Yeah? Don't try to use shared global architecture patterns on a cluster database like BigQuery. This will get a nightmare. So just use the prompting to say, no, don't use this, and it will work. So this is really amazing. The thing that we intend is that we also use LLMs for analytical record generation, so that you have like a 360-degree of the customer just composing data with support of LLMs, and to virtualize the semantic layers. And at the moment, we have heaps of data marts. The idea is to strip this down, and also to use Gemini in future for test case generation, tagging, and labeling of our data pipelines, so that we really get into fully generative software lifecycle that is really powered by Gemini, and all things we did from the slide deck worked out very good. So this is everything from my side. Back to Brian. Thank you for having the opportunity to present.
Thanks, Steffen. It's amazing work done at Deutsche Telecom, and it's really inspiring from a product team perspective to see the work they've done. It really gets us to innovate more and to deliver more capabilities.